So welcome to day 2 of International Symposium in Industry, Robotics and Healthcare, being jointly organized by IIT Kanpur and IPS Waseda University, Japan. So today morning, we are going to start our sessions with a special invited talk. And our speaker for today's morning is Dr. Nilanjan Chattaraj. So Dr. Nilanjan Chattaraj is an assistant professor from the Department of Electronics and Communication Engineering of National Institute of Technology, Durgapur. He is also an associated faculty of Center for Biomedical Engineering and Assistive Technology in IIT Durgapur. Prior to this, he worked as an assistant professor in Department of Electrical and Electronics Engineering of Birla Institute of Technology and Science, Pilani, and postdoctoral fellow at Department of Aerospace Engineering, Indian Institute of Science, Bangalore. He also worked as a software developer in Satyam Computer Services Limited and Motorola India. He received his BTech in Electronics and Communication Engineering from National Institute of Technology, Durgapur, and MS from Department of Electronics and Electrical Communication Engineering from Indian Institute of Technology, Kharagpur. He also received his PhD from Department of Aerospace Engineering, Indian Institute of Science, Bangalore. So his research interest includes smart materials-based sensors and actuators, structronics, mechatronics, soft robotics, following experimental approaches. So welcome Dr. Chattaraj to this international symposium. Over to you now.
So thank you, Anjumda, for this nice introduction. And so good morning to all of you who are in India, and good afternoon to all of you who are in Japan. And let me start now today's topic. So here I have thought to share some experience while exploring these things like assistive robots, and why shall we go for assistive robots which will look like something like a human being. Okay, so based on that, I have decided to discuss this assistive robosapiens with human-like emotions. You can read the title. It's fundamental and the technological challenges. Okay, now two things are different here: the fundamental challenges and the technological challenges. The two things are different. So since I have mentioned here understanding the emotion, so first we have to understand something which exists in human mind, the emotion, and then the technological challenges. It means that suppose you have understood something, now do we have the available technology to implement those things? So basically two different challenges are there. Now in this discussion, I have thought not to discuss any mathematical aspect, because many of you are almost like all of you are aware of the mathematical calculations, analysis, everything. But mainly I'll discuss from the perspective of system engineering, that what are the challenges if we talk about the robots. Okay, so it is basically this is based on mainly a system engineering perspective. And now let's move on. Let's move on with the slides and see now what we have now in this topic. Now the demand of assistive robots. Now all of you know that the demand of assistive robots that is increasing day by day. There are many reasons for that. So the requirement of assistive robot might come from any directions, and you can, so I have written some of those. For example, the physical impairments. For example, somebody is having like visual impairment or hearing impairment, or speech impairment. So many things can be there. So for that, they might require assistive robot to help them. And then this type of impairment that might come from, like, they can have that from their birth, or they might get this type of impairment at any point of time in their life. Then the second one is the rehabilitation at young age. So sometime we might not have that type of impairment, but we can lose some kind of physical limb, or for any kind of accident, anything. So that type of cases are also there where we require assistance. Then the third one is the healthcare support, that we don't have the impairment at this moment, and neither we have any kind of loss, any limb loss, any kind of loss, anything. but uh, we have simply, we have some health issue in general, but all the body parts are working properly, and for that we want some kind of assistance. Now we might be admitted to the hospital, or we might stay at our home. Now if we have some kind of assistive robot which can help us, that will be easy for us to manage our health. Okay, and also we can manage the something like, which is called the IoT based healthcare service, or the remote healthcare service. There are several names for that. So we can stay at home, then the robot that can perform its task based on my instruction, or maybe by understanding my emotion or my instruction, or maybe the robot can be operated through any kind of, tele instruction. So somebody on the other end, maybe in the hospital, they can provide some kind of instruction by observing my behavior through the robot, and then they can provide some instruction to the robot, and the robot will take accordingly some action. So there are several possibilities through which you can actually explore the this type of healthcare support, and then the assistive robots. And finally, the old age support, which is also a growing concern nowadays now. So in old age, the people, they are like, so mainly, two things might come now when we are talking about the old age. Considering that, sorry, they are physically fit, so they don't have any problem, any issue with their health. Okay, but maybe because of the old age, they might require some small assistance. They might require some physical assistance, and sometimes we call that one, partial assistance, not the full assistance. So they are dependent. They are independent, but they might require some partial assistance. And the second one is when they are staying alone. Sometimes they want some kind of company now. So that could be another requirement. Now, considering all these aspects, if we see, then we'll find that the demand of the assistive robot, that is actually growing day by day. Now assistive technology and assistive robots, they are like, I should tell you that assistive robot, that is a part of the assistive technology, but that is not the whole about the assistive technology. Okay, for example, if I cannot see something and I have a software and which can read the any kind of text what I have on my screen, and I can listen to that one. Being a blind, I can read that one properly, or I can understand that properly. So that could be assistive technology, but that is not the assistive robotics. Okay, so when you are saying assistive robots, you have a physical robot which can assist you through something. Okay, so here you can find that there are several fields are there where you can really require the assistive robot. Next, the motivation of this talk. Now, assistive, as I have mentioned here, the assistive robotics has achieved magnificent attention over the time in the healthcare support, as well as any other support which I have mentioned there. So we have a growing demand in that one. Now, considering its essence, those are designed to execute some task. So we have a robot. Suppose I require some assistive robot. Now, considering that the robot is supposed to execute some task, now the way the present assistive robots are available, so the robot that will execute some task, that's all. So considering its essence, those are designed to execute some task. But what is the main concern here is that, but they are not, they are, so they so, but they, okay, I something is, so they do not, basically, I should write here, so one grammatical mistake here. Okay, so they do not execute those tasks displaying a human-like emotion. Okay, so they just execute that task, which has a catalytic impact in the healing and the support system. Okay, so we have to keep in mind that we are not machine. There is a difference between industrial robot and the assistive robot. Now, being a human, we don't want something. For example, if I'm asking for a glass of water, it does not mean that somebody, a robot arm will bring at water, and that will put simply, that will put near to me. Not like that. Now, if the robot is carrying that water like a human being, so obviously I'll get a feel good factor there. So here it's not about executing a task. It's all about executing a task with the human-like motion. Is it possible? If it is possible, then what are the challenges we have? Now, so since I have mentioned here that if I have any kind of any health issue, or maybe any kind of old age problem, any kind of thing. So since I have mentioned here that human-like emotions, emotion has a catalytic impact in healing process. Okay, so it's not about executing a task. So if you support with a proper emotion, then the healing is better. Okay, now here the third point is that is that indeed possible to develop human-like assistive robot exhibiting human-like emotions in healthcare support, or maybe any kind of, maybe as I have mentioned in healthcare support, but it could be any kind of assistive support. Okay, so it is, so human-like, making a human-like robot, it is which looks like a human-like robot, that might not be too much complicated, but ensuring that that robot will behave like a human, that is really a challenging part. Now, can the evolution of Robosapiens, or sometimes these things are also called somewhere the humanoid, be a potential alternative to human healthcare or the assistive support? So these things I'll discuss now in this presentation. Now, considering the global market for disabled and the elderly assistive technology, now here you can see that now the market is a billion-dollar industry market. Okay, so two things are there. One is from the perspective of the emotion actual attachment. You can say that we want to make something which can really heal the human being. Second one is, if somebody is asking that if I want to make something, there should be investment, right? So if there is no demand, no requirement, then nobody will make it, or if the demand is less. Now, seeing this diagram, you can find that's a billion-dollar industry, and many people, they are now planning to invest in this one. And whenever you have investment, then that time we have a possibility that we can really make these things. Okay. So now the next slide, I'll show you now the share of users facing problems when using assistive technology in India in 2019. And here you can find that so here you will find that the statistics, the share of the respondents here. So the severity, it is going toward almost like 23% here according to the statistics. So you'll find that the demand is now growing toward the severe cases more. So that is also another statistics which encourages us actually to think for this type of robotics. Now, assistive technology and its applications. So already I have mentioned here that assistive technology and assistive robotics, if I take both the things together, then assistive robotics, that comes under the assistive technology. But assistive technology is a broad umbrella under which you will find many things. So I have mentioned some of those here. For example, here we have the assistive technology for the maybe for the impaired people. Okay. So here, for example, I have mentioned if something is there which can help us to read a book. Now, that could be a plain software which can be installed in a computer. So it can help me to study something. Okay. Or maybe here you can see the other option. So to take some kind of note, or maybe to make some kind of communication. For example, being a visually impaired person, I'm communicating with a person who is now speech impaired. Okay. So I cannot see that person, and that person, if that person is saying something, so I can only listen to that person. Now we can hello, yes, any question? Okay. So the communication devices between several impaired persons, that could be also part of the assistive technology. So if you take the broad umbrella, you'll find that several things are there which comes under the assistive technology, and assistive robotics is one of those. Now, coming to the classification of the robots. Now, if you see the robots and the robot service, uh, just 1 minute. Yes. So, if I see the classification of the robots, so here you can see that can be classified into two categories. One is the industrial robot, and the second one is non-industrial robot. So here you have the assistive robots, and you can write here non-assistive robots. And here further you can classify the assistive robots in non-social assistive robots, and we can have assistive social robots. Okay, so here you can clearly see that we are not, when you are talking about, some assistance can be given to the robot, it is not for the industrial application. Okay, we are like human, we are having emotion, so that robot should be a different one. So when you are seeing this one, that assistive, non-assistive robot, you can see the image of non-assistive robot. So seeing, this robot, we can feel that this is a robot, not like a human. Okay. Now here you can see this one. I have mentioned here assistive social robots. So social robots are there, but the most of the, the social robots, the way they are designed nowadays, now the social robots, they can socially interact, but if I really look for some kind of physical assistance, then the social robots are not made, for those applications. Okay, those are like for social interactions. And when you are planning for some kind of to execute some action, then we have regular robot arms we have, and that robotic arms that can perform the task. So basically, can we think something like, we have a robot, so something like, non-assistive, so something, a robot which can perform the actions of a non-assistive robot, but having the feature of the assistive social robot. Okay, so these things will be clear with the presentation, which when I'll move on with the presentation. But from this one, I hope that you have got some idea that assistive robots are special type of robot where we provide support to the human. Okay, so we expect that robot to to have some kind of features, the robot to have some kind of features which can feel the emotion of the human, or which can help a human like a human. Okay. So here I have categorized the assistive robot for elderly people. So here also you can see that, so this is the rehabilitation robot. So you can see here that we have some we have some wheels here, and then we have some arms. You can see all these things, and on the other side you have the assistive social robots. Now you can see the difference. Now here you can see the difference when I have shown here the companion type of robot, so that looks like kind of animal. So you can feel that as if this is an animal, this is not a robot. So you can feel that as if you are connected, you are connected with the biological world here. Okay, whereas if you see the image which is shown in the left hand side, the rehabilitation robot, now that looks like a machine. It does not look like a, something which will give me a feel that I am connected with this biological world here. Okay, now can we do some improvisation in this design which is shown in the left hand side, which can perform the task as well as which can make us feel that we are socially connected. Okay, so that is the main focus of this discussion. Okay, so assistive social robots. So I have just mentioned that several social robots are there which can give you a feel that you are socially connected. But on the other side, I have shown you in this one that social robots are not to perform too many tasks here. Okay, so now can we merge these two together, the social robots with this type of regular robots. So here we have the socially assistive robots. Now, here you can see now in these two images that the human beings are now interacting with the robot. But if I show you the other one, for example, this one. So here you can see the humanoid social robots. So the name of this one, the first one is the Sophia. You can see on the left side, and on the other side you can see the this one, Amica, other one. So here, by seeing the face of the robot, you can see that this type of robot, it does not look like this type of robot. So you can get assistance in this type of robots. You can get assistance from this type of robot, but you will not get the feel that you are socially connected. Okay, so you'll feel that, yeah, for sure that something is there. It is like, something is there which can assist me for something, or which can help me. But so it's not like somebody's there, so something is there. But if I show you the second one, you'll find that now somebody is there to assist you. Will actually, that will give you the feel as if you're socially connected. At the same time, you can do something. Now, as I have mentioned, that these are social robots, so made for social interaction. But if you are actually looking for some physical assistance, now we don't have actually this type of robot which looks like a real human being now, staying at home at the same time assisting in everything, like whatever demand you have now in terms of your requirement. Okay, now can there be something like combination of this type of robot which has much more higher amount of functionality in terms of executing support actions, okay, along with the looks of this type of social robot, where you can actually feel that you are socially connected. Okay, now so here you can see the comparative appearance, that the left side, what you have in the left side, now you can feel that this is like a robot, and on the right side you have a robot which looks like a human being. Okay, and obviously the second one that will give a feel that you are socially connected. Now, human assistive robot interaction. Now, what do you expect from a robot? Now, this diagram, this one, this shows on the beginning that so for example, I want some support from assistive robot. Okay, so I'm supposed to express some instruction to the robot so that that action could be performed. But sometimes if I don't have the ability to speak, so if I can express my emotion by some way, so emotion can also be some kind of interaction. Okay, for example, so give me a glass of water, that could be an instruction. But when somebody is somebody is sad, or somebody is happy, so depending on that, being a person, we know now how to behave in that situation. So that is not like a instruction, but seeing that emotion, we decide how to behave or how to take any kind of action based on that one. Okay, so expressing an instruction or emotion, both can be an input. Now suppose a person requires some kind of assistance from some kind of assistive robot, so the input can go to that robot in either way. Okay, so it can go through an instruction or it can go through an emotion. It can be either way. Okay, so mostly, if we say that it's kind of instruction, then it's a straightforward. So instruction can be provided any kind of straightforward voice command, any kind of switch, anything. But when you're saying emotion, it's difficult because you have to understand the concept of emotion, then you have to understand, you have to process the emotion, and based on that you have to decide. Okay, but when you're saying that I have a robot which can process now both, understand the instruction as well as understand the emotion, then it behaves like a human. Okay, because being a human being, we can process both. Now suppose that person has now provided some instruction directly or maybe through some emotion. Okay, now on the right side you can see here the assistive robosapiens. So suppose we have a hypothetical case, I'm saying you that we have a robosapiens which is very close to the human. Okay, so robosapiens with human like emotion. Okay, so it can it can interact with you, as well as it can help you in doing any kind of task through the feel that as if a human is doing for you. Okay, so here you can see that we have assistive robosapiens on the other side. So when the instruction is going through some emotion or from the direct through the direct instruction, so first job is now to understand the instruction of the emotion. This is the first task of the robot. On the right side you can see here the first one. Okay, so first you have to understand the instruction, understand the emotion. Understanding the instruction, direct instruction, is easy. Understanding an instruction through the emotion, that is difficult but can be done. Now the second one is to perform the required action. So you have understood, the robot has understood the instruction through the direct instruction or through the direct emotion. Now the robot is supposed to perform that action. And once that action is performed, then after that, so that robot might, it's not like the robot expects some kind of any kind of acknowledgement from that person, direct acknowledgement. But sometime if you expect that it is a social interaction where you are giving a feel to the person that the person is socially connected. So obviously when somebody helps us, we say that any kind of any word, thank you, or maybe anything. Now if I say that now I have a machine and the machine does not deserve thank you. Actually, thank you, it will not make a difference here, because who cares whether if I'm saying thank you to a machine or not. But if I can get a feel that this is not a machine is like a human being, then that will give a feel that as if I'm not alone in this room, I have something, like not like something, somebody with me in my room. Okay, so just ensuring the human behavior of him or human interaction, what we do exactly being with the robot. So conveying the acknowledgement to the robot, at the same time the robot is now conveying now another acknowledgement. Okay, so just to make sure that it is not an interaction with the robot, it is an interaction with a human like robot. Okay, now so here you can in this diagram you can see here the difference. So the robot is carrying a human being. Now this, suppose this person is now sick and the robot is carrying this human being. Now imagine a robot which appears like a human and then carrying this human being. So obviously that probably the task will be performed for both the cases, but surely there will be difference, that that person will feel it's not a robot, it is like something which looks like very similar to the human being which is carrying me to the bed now, okay, for any kind of healthcare support. Okay, so it's a kind of feel good factor, but at the same time very well that emotion that plays very important role in healing. It's not like carrying somebody just to carry somebody from one place to another place, not like that. Okay, just ensuring that you are carrying that person with proper emotion which that person expect now. Okay, the scope of assistive robosapiens with human like emotions. Now first of all, let me tell you one thing clearly, that whatever technology we have at present, if my objective is to develop any kind of robot which can perform some assistive action, it is actually, it can be done if I have funding, that's all. So if funding is there, then a customized assistive robot can be designed and developed to perform almost any task. There is no doubt on that one. Now there we have actually we have enough analytical methods, mathematics, everything is there, but whatever we have, the technology we have, if my objective is to perform a task, just a task, then the technology is there. Now in industrial robotics, the receptor is another machine, so I have mentioned already earlier. Okay, so in industry, suppose I have a robot, so there is a robot which is helping to design to weld any kind of to perform any kind of welding in a car. The car is a machine, and the welding machine, that is also another machine. So it's basically machine and machine interaction. Okay, so we are not a machine. So it is not about executing a task. So the third point says that the assistive robots are not industrial robots where the task is execution is the prime interest at any cost, not the task only. Okay, so assistive robosapiens is aimed to be a companion of human being. Okay, so if you perform the task with the behavior of a human being, that can surely make a difference. Okay, so here is the scope of the assistive robosapiens. It's not about performing the task like a human being. And in assistive robotics, the receptor is a human being, and that is the reason you have to take care of one thing. In assistive robotics, the receptor is a human being whose thoughts and actions can be influenced by emotion exhibition of the assistant or the companion. Okay, and that is the reason, if you incorporate the functionality to understand the emotion in that robot, at the same time to give response with emotion, that will surely make some kind of difference. Okay, so the emotion can be interpreted as an impedance here. Better, that could be a good example if I correlate this one with the in engineering designs what we have. So all of we are aware of the impedance, and emotion can be interpreted as an impedance here, and emotional connection can be interpreted as an impedance matching in engineering design. Okay, so if you want the companion to do a task with a certain type of emotion we expect, so obviously the objective of performing task will be much more satisfactory for that case. Okay, so it is kind of impedance matching. So you have to match the expected emotion so that the receptor can get better help here. Okay, so what is emotion and how to express or receive emotion, the scientific aspect now. The emotion display is the manifestation of mood basically. Now through the, so you can show your emotion through the functionality of physiological sensors and the actuators. Okay, so emotion display, so I think one thing I should make it clear. Yes, so emotion display is the manifestation of mood through the functionality of physiological sensors and actuators. So I have basically mentioned here sensors and actuators both here, though I have mentioned here emotion display. So basically, emotion display, this is associated with the actuators only because you are showing something, you are displaying something. Okay, so sensor is associated to the input, but there is a reason for how I have mentioned this one, that you cannot show the proper emotion if you have not received the requirement of that proper emotion. So first you have to understand the ambience, or understand the requirement of the patient, of the receptor. Okay, and then only you can show your emotion properly. So basically you'll find that now if I correlate this one with the physiology of the human being, so you'll find that we have five biological parts through which we can get the input. At the same time we can there are certain parts through which we can interact with the physical world. Okay, so input normally you get through the eyes. So eye, so we can see something, then we can touch something, so touch is another type of sensor. Then so here, so basically, so here I have mentioned here emotion display. Okay, so when I have mentioned emotion display, basically I have here mentioned basically both the things now, the input and output. The way we take input and we provide output to the physical world, both the cases. Okay, so here you can see that we can see something through our eyes, we can express our emotion through our eyes. Okay, so we can feel the touch of something, or you can understand the emotion. For example, if somebody is holding my hand with emotionally, you can feel that one. At the same time, when somebody is pulling my hand, that also I can feel. Okay, so here both the cases are there. So similarly, if I am pulling somebody's hand forcefully, that person can feel that it is not any kind of, so that maybe so I'm angry, so I'm pulling that person, or maybe I'm for some reason I'm pulling that person. So basically you can understand the mood there. Okay, so touch, so touch can be touch, the concept of the touch can be interpreted in both the ways, as input, as output. Similarly, the functionality of eye can be interpreted in both the ways, taking the input and the output also. Okay, so you can see something and then you can you can show some emotion with your eyes. Then you can speak something, so speaking something, that language and the voice, it has huge impact on the emotion. Okay, so here you can so this is another part through which you can you can express your emotion. Then ear, so ear, through ear we can take the input only, and if we hear something, so listening to that words, so listening to that words and processing that words in my mind, I can decide whether that words what was the mood or what was the emotion of that word. Okay, so nose is another sense organ, but most you'll find that this is not associated with the emotion as such. Okay, the way we interpret this emotion in terms of engineering design. And obviously muscles, it has huge impact. Now if you see these images, you'll find that it's the muscle basically which we can change the facial expressions. Okay, so muscles has huge impact on the emotion. So basically when I'm saying that it's emotions, we have to understand now not many things but few things only. So if you understand the eye, if you understand the eye, if you understand the touch, that one, the touch behavior, then the way we speak, then we hear, and the muscles. So you have to understand these things. Okay, emotion reception through typical physiological sensors. So here I have mentioned that we have mainly 1, 2, 3. So three inputs you can take. So you can take input from three biological parts you can take. Okay, so human with no sensor, no reception of emotion. Okay, so you can correlate this word also, that I cannot see, I cannot feel the touch. I have nothing basically. Okay, I cannot hear anything, or I cannot smell anything. I have nothing. Okay, no way to sense anything. So if a human being having no sensor, then there is no reception of emotion here. Okay, so it means that you can connect the sensors with the emotion. So something is happening through the sensors only. Okay, so through the eyes. So through the eyes means now you can see the facial expression and the body language. Okay, to understand the emotion of someone. So when you are seeing something through your eyes, you can see the facial expression, you can see the eye expression, you can see the body language. Okay, now when you are doing this one, you are basically doing now optical processing. You are doing optical processing, you are doing image processing, you are doing video processing. Okay, so I have a camera, being a robot, I have captured the facial expression of the body language, body movement, and then I have done optical processing. So it is basically nothing but image processing and the video processing, and then you have understood the emotion of that person. The second thing is through the ear. Now listening to sound, the way we pronounce the sound. Okay, for example, thank you, that's a word, that's a kind of it's a set of now two words. Now thank you, but it can be pronounced like thank you and thank you. So two different expressions are there to express that that set of two words. So when somebody is saying thank you, it does not mean that that person really wants to thank you, provided the proper emotion or provided the proper expression is attached to that word. Okay, so you can correlate now through the ear. So when you are listening to that sound, so basically two things are there. One is the language, and then with what type of expression you are receiving that language through your word ear. Okay, so listening sounds, listening to expressions, and then speech. So speech means now you have to understand the language. Okay, so when you are taking the input from through this one, then you can, so then you are doing basically audio signal processing. You can do audio signal processing, you can do speech processing, you can do music processing also. Okay, that is also a very important thing, because we know that music can be made for for happy mood, for sad mood. It means that it has something to do with the sound, and if you analyze the sound properly, it's basically signals, right? So it means that there are certain frequencies which can trigger your mood now. So it's simply signal processing. And the last one is the NLP, natural language processing. So being a robot, I have heard some language, then I have to process the language. Understanding the language, I can find out the emotion. That is also okay. So here you'll find that when I'm writing these things, these are technical things, basically the audio signal processing, then the speech processing, then the natural language processing. So these are technical aspects. Then another option is now through the skin, feeling touch. So feeling touch means now when somebody is holding my hand, now two things might occur here. One is the pressure processing. So with how much pressure I'm holding. So I cannot have a robot which does not have any sense how to hold the hand with how much pressure. Okay, and the second one is the temperature of that robot. Suppose there is a robot, but the temperature in cold winter, the robot is having like 0 degree temperature and holding my hand. And the second one is in hot summer, suppose the robot is having a temperature like 50 degrees centigrade, and then the robot is holding my hand. So in both the cases, I can feel that this is not a human being. Okay, because when the human being is touching us, then we can feel the pressure. At the same time, we can feel the heat exchange, because we are sharing the similar type of, when two human beings are they are touching, then they are having almost like same body temperature. Okay, so there is a mild amount of heat exchange there. So basically two things are there, the pressure processing and the heat exchange processing. So when you are making a robot which can give us the feel of the socially social connection, at the same time they're assisting us being at home. So when the robot is helping us through something, making any kind of thing, so you have to ensure the robot is now sharing proper heat exchange. At the same time, the robot is now sharing proper pressure here. Okay, and finally, the synchronization of all the three is desirable to take a decision, to take any action based on the emotional reception. So we can have either one, okay, but at the same time, if we have all the three, then you'll get the best, the assurance that it is the same emotion, because you know that the same emotion can be expressed independently through the eye, through the ear, through the skin. Okay, so here you'll find that if you are synchronizing everything, you'll get a better response, better and so better reliability that it is the same emotion. Okay, because if you interpret the emotion wrongly, then your action could be a wrong one. Okay, then the creative thinking is the cherry on the cake, which is the toughest to achieve. We are not talking about the creative thinking, because we cannot expect now creative thinking from a robot. Okay, so forget about that one. We are talking about only the decision. That's why I have mentioned here synchronization of all the three is desirable to take a decision, to not to make a creative thinking. Okay, so for the time being, we can assume that it is enough if that robot can take a proper decision. Okay, now when I'm saying that, so many things you have to understand, the voice, you have to understand the natural language processing, you have to do the video processing, so many things are there. Then obviously you cannot keep this one apart from your discussion, the requirement of the artificial intelligence, the machine learning deal. Okay, because when you are targeting to understand so many things now, to interpret the emotion, then obviously there should be AI ML application. Now, so the previous slides, that is associated with the reception of the physiological sensors. Now here, the emotion expression through typical physiological actuators. So being a robot, so suppose I have understood the emotion now from the first slide, but the previous slide which I have discussed now. Now the second one, now I'll take some action. Now human with no actuator, no expression of emotion. At the same time, if no actuator is working, for example, my eye cannot move, okay, then my hands cannot move, many things cannot move. Okay, so many things cannot move, so that's the reason I cannot express my emotion. But there is a catch now. So you can see that if I see an image, so seeing an image, I can feel that that person is sad. So there is no actuator, nothing, right? That's only image. So seeing an image, how can I see? For example, see this one, a sad. So at the bottom corner, you can see one, a sad eyes. So there is no actuator, right? It's a visual impact only. But how can I interpret the sad things when there is nothing, like no actuation, nothing? So that is coming from my previous experience. Okay, I have seen that this type of eye expression is associated with the sad expression. Okay, so if you have not seen something, so obviously you will find that if you have not seen something similar to this one, you cannot interpret that it is really any kind of so whether this is saying that's a sad expression or not. Okay, so it means that the human with no actuator, really you'll find that no expression of emotion. But when seeing an image, you are interpreting the expression. It means that you have previous expression where you have seen basically the emotion which is expressed with some kind of human actuator. Okay, biological actuator. So what are the actuators now? Through your body muscles. So through your body muscles, you can show your expression, emotion. For example, the eye expression. So eye expression can be that can be controlled through your eye muscles. Then the facial expressions. So here I have shown you some of the images. So if you want to show some emotion through your facial expression, then here you have to incorporate some actuators on your face, distributed actuators on your face. And the last one is the body language. Sometimes I'm not moving my eyes, or I'm not showing something, anything on my face, but I'm showing something through my other body parts, for example, through my hands, through my body gestures, or through my legs. Okay, so here you'll find that the body language could be a part through which you can show your uh, emotions. Okay, then the emotion could be static, such as the painting or a sad face, or maybe a sculpture with a happy face. But I have mentioned here, so static things cannot make emotion. Okay, so you can interpret the emotion of a static thing from your past experience. Okay, and the past experience is developed through some kind of real experience. Okay, so here you have the second one, the dynamic expression. So seeing the real-time expression. Then after that, through the voice. So you are saying something through your voice. So some instruction. For example, I have told you the thank you cannot be an instruction. Okay, so the way we provide instruction with that tone, you cannot say somebody the thank you. Okay, so through the voice, so expression and the speech and the language. So here you can understand that. So here you will understand that. So we can also express our emotion through some kind of voice, through some kind of statement, some language, some sentence, anything. Now when you are speaking something, that is also an application of muscles. But here I am keeping this one separate because eye muscle movement is actually different from the tongue muscle movement, because that is now creating something different, which is the acoustic signals now. Okay, so I've kept this one different. So when you have acoustic, then you have now audio signal processing, then you have speech processing, then you have NLP. Okay, now so here you'll find that the interesting part I have mentioned already, that emotion can be expressed through any kind of song. So you can do any kind of frequency analysis there. It can, we have different ragas also there to understand the different type of mood. And then the through the skin, feeling touch. Okay, by applying some kind of pressure on the human skin, or with the proper heat exchange, you can also express your emotion. And the same thing is applicable here also. Synchronization of all the three is desirable to convey the expression with proper emotion. Okay, for example, what I am saying, along with that, my body language is also expressing the same emotion. Okay, so for example, my language, my expression, then my facial expression, my eye expression, my body language, everything is synchronized. Then you are sure that this is the impression. But sometimes it is deceptive because my facial expression is not synchronized with what I'm saying. Then we say that it's a deceptive one, and you cannot interpret the emotion properly. So when you have synchronization, it is easy for you to understand the emotion. And here also, when you are doing so many things, then you cannot avoid the requirement of artificial intelligence. So AI, ML, and DL. So this is not AL, it's AI. Sorry for that mistake. Okay, AI, ML, and DL. And finally, we have the implementation of a task not like a robot, but like a human. Okay. Now, why this is necessary? Now, by this one, probably by this discussion, you have understood one thing, that this is very important term, that handle with care. Okay, so it is not only for you have a glass, showpiece, and you have to handle this one with care. Not like that. Even if you are human, we have to also handle the other human with care. Okay, so the important part is handle with care. It means that it's not like take that person and put that person on some chair on any kind of bed. Handle with care. Okay, now to ensure that you are handling the person with care, you have to ensure that you are handling the whole thing with proper emotion, and you are ensuring the receptor, the person, human being, so that person is also now satisfied with the way you are performing the task. Okay, the robot is performing the task. So the availability status of few things, just to ensure that these things are actually possible, that we have Robosapiens, or we have humanoid with human-like motions. So we have understood one thing by this time, that we have basically now three things now: requirement of the sensors, requirement of the decision-making system, and the requirement of the actuators. Okay. Now, considering that one, the requirement of sensors, we have plenty of sensors to take the proper sensor input. Then at the same time, you have plenty of advanced computation system. There is no issue with that one also. Okay, we can plenty of computation system. And the third one is the suitable actuators. Plenty of actuators we have, but the most challenging part is when we think of an assistive robot to be like a human being, since that is desired to be made of for a human. Okay, so the most challenging part is you are making assistive robot for a human being, so you expect that action should be like a human being. Okay, so you cannot make a robot with a motor, because that will not replicate the actual human actions. Okay, so this is the reason you can think of the biomimicking in terms of application, because you are replicating a human behavior, so there should be some kind of biomimicking there. Okay, so basically we want assistive robosapiens with human like emotions there. Okay, now let's see the overview of assistive teleoperation architecture. Okay, I have few more slides on it though. Okay, I'll take maybe another 5 to 7 minutes. Okay,
yeah, so we have a lineup session starting at 11:55, but it's okay, fine.
I'll take five minutes only. Okay,
oh, sure.
Okay. So overview of assistive teleoperation architecture of any kind of robot here. So you can see here, this side you have a robot. So we have some scope of user input. So you can integrate all the sensors here, and robot sensors here, other sensors here. And here you'll find that all these things can be connected through the internet here. So in between you have internet, in between the sensors and the robots, you have some sense. So you can have this robot. So basically, if I sum up all these things, So you'll find that, so here we have a person which can interact with this robot. The robot can take all the data, it can send the data to the internet and take the decision, and accordingly it can take the action. Okay, so it means that understanding the emotion, it is not a difficult task nowadays, because if you take the input, you can take all the data, you can send the data to the cloud. We have huge data computation power in the cloud, so you can use or implement their machine learning, their artificial intelligence there. You can perform everything easily now. So understand the emotion, and accordingly you can take the decision. That is not a big task now. Okay, now the big challenge is to get human-like actuation in assistive humanoid robots. That is the most challenging part here. To execute a task in a controlled manner, that can be done. To execute a task following human muscle operation. So here you'll find the most complicated task here. Okay, that motor actuators might be a good solution, but that is not the best one, considering that you are making a robot to assist a human being. So soft flexible actuators are preferable. Biomimic actuators can be a good option, and then soft flexible miniature actuators are required in many places, such as eye expression. So you cannot use a motor there to get all these biological actions. So to execute a task like a human, with a human-like emotion, to give the receptor a feel like that person is socially connected. So you'll find that the most complicated task is now to get the most complicated task here. Okay, so considering that that discussion, let me come to the conclusion. So we want to be socially connected. So we want to be socially connected with human, not with the robots. That's primary objective. Okay, if we are making an assistive robot, we have to ensure that the person should not feel that they are connected to the robots now. Second one, we expect an assistive robot to execute a task like a human, with a human-like emotion, to give the receptor human a feel of being socially connected. Okay, so that is another one. So I have explained here that emotion can be interpreted easily. Okay, the problem is now you cannot perform the task with the because you cannot replicate the human muscles. Okay? So we prefer to have an assistive robot with the features of the social robot. We have assisted robot, but the social robots are not available with the features of the assistive robots. So basically we want now the combination of both. So now I have summarized these 3 points now. So first one is to understand the emotion. So this is challenging, but can be understood using sensors and AI. That can be done easily. We have internet, we have the cloud service, we have the processing powers. Then taking decision, so challenging, but can be implemented even through the computation in the cloud. Okay, we have enough resources for that. Now that taking action like a human, this is the most challenging part, because considering the you are making you are helping a human being, you cannot use a motor type of actuator there. So if you can replicate the biological actuators, that will give a feel that you are really making something like for the human being. Okay, so with this one, thank you to everyone for listening to the session. So if you have any question, you can ask.
Thank you, Dr. Nilanjan, for such an insightful talk. I would request some question from audience. You can raise your hand.
Yes. Can I ask?
Yes.
Yeah, please. Yeah.
Okay. This is the Hiroaki Wangatsuma in the Kyushu Institute of Technology. Thank you very much. The interesting talk. So I'm a bit curious. I mean, the professor, there is a big gap in between the non-introductory the part and the implementation part. I totally agree the importance of the a kind of the emotional reaction in the robot if it's smoothly interactive with human, and you are emphasizing the first part, but you are saying that the last part, in the implementation part, you just emphasize the actuator or soft material, but as you said in the introductory section, some kind of interactive process is very important to reproduce the emotional reaction. And then even if the elderly people or children is not so stupid. If just a machine, that they understand, oh, this is a machine. Okay, that's why you emphasize that such a smooth interaction is very important. But this is not only the sensor issue. You need to think about the neuroscientific internal model for the interaction, some kind of things. I think you have some more idea for the real implementation of that. Could you answer on this point?
Yeah. So I have discussed this one from the perspective of now system engineering. So I have not discussed many things actually. For example, let me tell you about that one, that EMG sensor. Okay. So that could be one another option. For example, now you can correlate that whether I'm feeling sad, happy, many emotions can be interpreted through that type of signal also. Okay. So my objective was to present the whole thing from the perspective of system engineering first of all. Okay. Second one, I have mentioned only few options through which we can take the input and we can understand the emotion. Okay. But I have mentioned few of them. So considering the time limitation, I have not mentioned many of them. Okay. For example, so we can also integrate, for example, whether somebody is tensed or not. We can also we can integrate the ECG sensors with that one, ECG sensor, the EMG sensors, along with that what that person is seeing. So many things are there. We are not going deep into that part, but from the discussion, I should one thing I can conclude. I should tell you that interpreting emotion is it is really difficult task. Surely that is really difficult task, but I'm not saying that we have to understand all the emotions. Okay, just to perform the task. For example, the basic things. For example, the basic things means now for example, the thank you, that word I have mentioned here, that or maybe or maybe the basic one. So for example, if somebody is feeling now sad, now we want some kind of some kind of good interaction, or maybe good support from that person. Now if I can see the face of that person and if I can understand that the person is feeling sad, so that is actually a good support. Okay. So I'm not saying that all the emotions can be interpreted properly. That is really a huge challenge. So the objective is not to to go toward that side. I'm saying that considering the task which is targeted by all these assistive robots, the basic stuffs, basic healthcare support what we have now. Okay.
Yes, thank you very much. Yeah, I agree that the sensor issue is important in the EEG or EMG or other sensor you can integrate. But I just wanted to ask the data, how do you integrate such a multiple types of data, then convert to the kind of emotional reaction? Because this is not just a summation, as you said. Okay, that's why I just wanted to ask that kind of idea or the actual method such as what kind of best integration is possible. Okay, sorry for taking time. Just I wanted to ask the such a more advanced idea for this.
Okay. See, my objective. So in this presentation, I have mentioned here, our objective is not to explore the whole emotions of human being, but to ensure that the task which will be performed by the robot, if you can add some emotion while doing the task, that can give a healing to that person.
Okay, thank you very much.
Okay, thank you.
So in the interest of time, we can take one more question from audience, if there is any. Okay, thank you, Dr. Nilanjan, for that insightful talk. We'll move ahead with our technical sessions for today. And may I request Nayan to introduce our next speaker.
Thank you.
Okay.
Thank you.
Once again, thank you, Professor Nilanjan, for such a nice talk.